So today I want to talk about the Zig programming language. It's a relatively new language. I'm quite excited about it, and I think it could be the future of systems programming. There's been a lot of languages that have tried to be the future of systems programming. There's Cyclone, which no one remembers. There's Rust, which stole all of Cyclone's features but had better marketing. There's D, which had a good name but tried to do everything and sort of didn't do anything that well. But I think Zig has all the tools to be the chosen one of systems programming, to finally sort of start replacing C in a meaningful way. So I want to introduce you to Zig. I maybe want to try and convince you that Zig is worth looking into, or at least convince you that it's an interesting language in its own right. And if I could do the next slide, that'd be great. There we go. Okay. Is there going to be a bunch of delay, is there? Yes, of course, it's Windows. Right. So, how long will this talk be? I timed it before. It was 28 minutes, but I was vamping a lot. So I think this should be down to about 25 minutes, so plenty of time for questions if you guys want to jump in. Don't feel shy. There's not many of us. You may as well just butt in if you have questions. So, we'll start off with a very high-level overview of Zig. I would call it a middle-level language, a systems programming language in the same category as a C, a C++, or a Rust. So I think one of the key features is there are different allocators are first-class citizens in Zig. There is no global allocator. You explicitly have to say what allocator you're using every time you allocate. It's not baked into the language. Which we also will see a bit later is quite useful and really quite cool. Big feature is it can compile and use C code directly, which I think is a really useful thing. It's actually used at Uber as a cross compiler, Uber the taxi company. They use it to cross compile their C code because the cross compilation in it is that good. It's quite simple, especially compared to the likes of C++ and Rust, which are very complicated, big, hairy languages. It's much more like C in terms of its simplicity. And Zig programmers are called Ziguanas, and there are some subtle references to iguanas in the rest of this talk, and see if you can spot them all. So this is a functional programming talk. We like to talk about functional programming, and Zig deals with memory allocation, layout, representation, bit bashing. So what's relevant about Zig to functional programmers? Well, to start off, a couple of you asked me to talk about it, so that's probably one reason why it's relevant. But I think on its own merits, it's metaprogramming and it's compile time programming and probably of quite a lot of interest to functional programmers. It does make it a bit different to other languages, which I'll get into in a minute. And I think it has a pretty good solution to generics and compile time metaprogramming and calculating things in advance. And we'll go over that now, and it's called CompTime or compile time. So let's take a look at that in action. Actually, no, action is the next slide. Let's look at a brief overview of what CompTime is. This is just from the Zig website. Basically, they have one mechanism for metaprogramming. They don't have multiple ones like C++ and Rust, which have macros and generics, which are sort of separate things, even though Rust macros and C++ macros are very different, but never mind. It's quite simple and easy to use. Like, I'm not great at this stuff, but I got started with this and productive with this very quickly. And yeah, the next slides we'll go over brief examples of how the same construct can be used for a lot of different aspects of compile time programming and meta time programming. So the way to do generic functions is with CompTime. Hopefully this should be pretty easy to read. You'll note that the first parameter has a CompTime prefix and the type of it is type. So this is basically how you do generics in Zig. They are just another function, but one of the parameters is CompTime and takes the type of type. So this is, of course, all statically compiled. If you made a max function with a type that didn't respond to this operator, I'm not sure if you can see my mouse, but I'm hovering over the operator here, it would fail to compile. But yeah, this is your basic generic functions in Zig. So how do you do compile time programming? You also use CompTime. So here we have a way to calculate the first n primes, which could potentially be quite expensive, depending on how many primes you want, I suppose. And it's the exact same construct. So if you're not sort of too familiar with systems programmers often try and calculate large values or expensive values before the code actually runs, so the compiler actually does it before the executable even starts, so the data there is available in memory. If you've ever used C++ templates to do similar things, I hope you'll probably appreciate that this looks quite a bit nicer. It's basically just the function, the runtime equivalent, but with a comp time in front, and you kind of get it for free, which I think is really cool. Generic data structures. So this shows you some interesting things about Zig. First off, comp time again, no surprise. Second off, a generic data structure is just a function that takes a type and returns another type. Functions that take types and return other types are, of course, comp time constructs, but it's using a few orthogonal features to do like a simple thing. It also shows you here that Zig has struct literals, which is basically how you define all structs or records or whatever you want to call them. And I think, yeah, it's a good example of Zig having a few orthogonal features that do a lot of things. This one comp time can replace C macros, C++ templates, aspects of Rust macros, Rust generics. It's one thing, and it's all quite easy to read and use. So, yeah, all code is sort of functions, but some functions just happen to take place at compile time, and those are comp time functions. A particular interest of functional programmers is that in Zig, modules and structs are the same thing, which means that it's not too tricky to do something like standard ML or OCaml's functors, which are parameterized modules or higher order modules or modules that take other modules as arguments and produce further modules. This is pretty easy to do in Zig using the same constructs I showed before, but I guess I leave that as an exercise to the reader. So yeah, that's Zig's compile time and metaprogramming capabilities. So another great feature of Zig, very practical, and one of the killer features of Zig is that it's very at home in the C ecosystem. I've mentioned this before, but I do want to reiterate, it can compile C. You can import C headers and use C code directly. There is no foreign function interface like you have to use with Rust. You don't even need to have header guards like you do in C++. You literally just grab the code and Zig compiles it, which means everything in the C world is trivial to use. So why is that important? Because there's lots of packages in C. There's lots of libraries, a huge number of libraries. Many of them have been, contributed to for decades, are high quality, have millions of users. Think about your curls, your SQLites, your zlibs, and you can use them in Zig straight from the OS. You don't need to wait for someone to write bindings around them or a foreign function interface around them. You can just use them straight away. So why is this great? Well, it means you don't have to deal with wrappers. Wrapping can get out of control for foreign functions. You could have multiple levels of wrappers for one library is very common. For example, almost all Rust crates have 2 or more wrappers. There'll be a sys library name wrapper, which is the low-level, unsafe, C-like interface, whatever they call it. And then there'll be like a quote-unquote idiomatic wrapper around that. And me personally, I often don't care about someone else's idiomatic reinterpretation of like an industry standard library that's been in C and been written for decades and blah, blah, blah. I'm not really that keen on other people's take on it because the documentation of the original library is usually so much better. You can use, and it's always better to use the libraries without the overhead of the wrapper or the extra function calls, especially in systems programming contexts. Which is why I think not having to have wrappers in the first place is a good thing. So the conclusion here for me is that Zig has a massive ecosystem out of the gate because it can just frictionlessly use everything in the C world, whether it's from your OS package manager, you want to dynamically link it, statically link it, Zig can use it really, really easily. So memory management is a big topic in systems programming languages. And I don't know if any of you guys used to read Slashdot, but it had lots of car analogies. And the car analogies were always really watertight. They never got stretched. They always held up. So I'm going to use some car analogies to sort of explain how I think Zigs memory management fits in to the general world of programming, of systems programming. So let's start off with early manual transmissions. They were very slow. They were kind of error prone. They were very tedious. You'd have to double clutch, which is when you have to shift the gear from the gear you're in into neutral, and then from neutral press the clutch again into the gear you actually want to go to. The other option was float shifting, where you didn't use the clutch at all. You had to match the RPMs exactly while you were in neutral. And if you got it wrong, you would damage the engine. So this was slow, error prone, easy to screw up, annoying to do, and we've largely moved on. So, in case you didn't sort of pick it up in it, this analogy is basically what C memory management is for me. Maybe C++ could be the regular transmissions that were synchronized, but anyway, we won't go too far into it. So most people now have moved on to automatic transmissions. You don't have to constantly use the clutch. They're pretty damn reliable. They're very forgiving of driver mistakes. And let's be honest, they're usually fast enough for the vast majority of what we do. And there's is a very subtle nod, of course, to garbage collection, which is for the majority of programming these days, probably the right choice. And then we move on to dual clutch transmissions, which still use a clutch. They're relatively new, at least in commercial sort of passenger cars, but they have two clutches, one for odd gears and one for even. When you shift gears, it automatically engages both clutches, so there's a very short time between switching from one gear to the next. They do require more care than automatic transmissions. They're more expensive to develop. They're harder to screw up than the old manuals, but they require a lot more maintenance than an automatic. So for me, I'm using this as an analogy for how Zig deals with it. Of course, car analogies are flawed. Here's an AI-generated image which looks completely stupid. Looks like it's two rear ends of a car, but let's get back to some concrete discussions of Zig. So with Zig, you decide, each time you allocate, you decide what allocator you use. Every single function in the standard library that allocates memory has an allocator parameter. So you can even make your own allocators. Allocation is like is a type signature that you can implement. So you could make your own. Zig, however, does include several out of the box, and I want to briefly go over why you might want to use them. Also, why it's hopefully sort of get across why it's great that they're there at the base level and that you don't have to implement them yourself like you do in most other systems programming languages. So the simplest one is a fixed buffer allocation. So this is useful in situations where you know how much memory you're going to use or when you can't use heap memory at all. So a good example for this is very tight game loops where you know the amount of memory and you don't want to allocate during the loop to make it nice and fast. Certain parts of kernel programming where you want to be sort of relatively real time. It's how a lot of embedded programmers have to work because they may not have an allocator or sort of they may not have a standard page allocator, because there's no operating system, and they may only have a very small amount of memory they can use anyway. But by using a fixed buffer allocation, you can still use data structures without malloc. Like you could use the fixed buffer for things like hash maps, linked list, dynamic arrays, without having to have an operating system to deal with memory management for you or to deal with memory allocation for you. So that sort of brings some high-level constructs into embedded programming. The other one is arena allocator. So for those not familiar with this, arena allocators are or at least in Zig, they're implemented as like a higher order allocator. And what this means is that you can allocate many times. The allocator keeps track of where you've allocated, but you free once and it frees them all. So this is useful for memory that has the same lifespan and where you may not know exactly how much you need. Now, in my opinion, in C and C++, this is like an advanced pattern to do arena allocation. It's quite... Well, look, for someone with my skill level in C and C++, it's quite error-prone and tricky to do this kind of thing. It's completely trivial in Zig. And because it's so trivial in Zig, people do it a lot, and it cleans up code a lot because you really only have to free the once. So yeah, that's a really great advantage of having it in the library and having the pattern of first-class allocators in the first place. And last but certainly not least is the testing allocator. So as I mentioned before, standard library functions that allocate take in their own allocators. Your functions that allocate should also take in their own allocators, and that way when you test your functions you can pass in the testing allocator. It detects memory leaks very, very quickly. It's a bit like Valgrind if you've used that for C or C++, but it's integrated deep into the language, and it works in your test code. So in Zig, tests are a part of the compiler, as they are in D and Rust and various other languages these days. So it's basically like a mini Valgrind that you get sort of for free in the language that is very fast and easy to use. So an important question really is, how safe is Zig? I mean, you are technically managing your memory manually. So is it just as dangerous as C? I would say no, for a number of reasons. Failed allocations are an error, and in Zig, you cannot ignore errors. There are language constructs that let you free at the end of a block, any sort of block you want to free at the end of. When you use arena allocations, you're allocating a lot less memory anyway. With the testing allocator, it's very trivial to find real-life leaks and actual running code, not just theoretically like some languages, which we'll get into later. So basically, Zig is as safe as your test coverage is good. If your test coverage goes across all your allocations and frees, and you're using the testing allocator, you are really good to go. It doesn't pretend that it can determine it all statically. But it also lets you still have a very high degree of memory safety in a pragmatic way, in a sensible way, and gives you like C levels of control of when and where you free it. So it really tries to do the best of both worlds, and in my opinion it largely succeeds in this. So when mentioning Zig or any systems programming languages, there's an elephant in the room. There's one language that people always want to compare it to, they always want to bring it up, and that language is Rust, which is in the same space, which is also reasonably new, at least in the compared to in the category of systems programming languages, it's reasonably new. And this talk really wouldn't be complete without me having a bit of a comparison of the two languages. So here is my take on the battle for systems programming language supremacy. As a bit of a background, I spent about 3 months learning Rust. I was more productive in Zig after about 1.5 months. It really wasn't even close. And I've said that it's the most productive I've been and the most fun I've had where I've dealt with memory and pointers and allocation and references and all the rest. C and C++ are exercises in frustration. Rust gets so close for me, but also ends up being an exercise in frustration. And Zig, for me, gets it exactly right. Your mileage may vary, of course. But anyway, I'm going to go over what I think the differences are. So here's my controversial hot take on the issue. The borrow checking and the ownership thing in Rust sounds great in theory. It works well 95% of the time. It attracts a lot of attention and hype because, I mean, wow, it's really fast and it's completely safe. And there are no downsides. But there are downsides because there's really quite a few edge cases you'll run into, or at least I run into, dealing with the borrow checker for cases it can't handle. Like if the borrow checker and the ownership model was completely accurate and could handle things that it should handle, and these are examples that I've like shown to Rust people in the Rust developers, and I've said, I've sort of asked, hey, why doesn't this work? And they've admitted that it's a bug, and I found that sort of relatively early in Rust, which doesn't bode well. And people really tend to make convoluted Rust code in order to please the borrow checker, in my opinion. So that aside, there's a few differences about this here. Rust handles memory implicitly. The frees are implicit unless you call drop manually. Zig makes it all explicit. It's all out there, but it just gives you first-class tools with dealing with it. It's nowhere near as annoying to use as it is in C and C++. Rust is, I would call it a kitchen sink language. It's a very large and complicated language, a lot of cool features, but the intersection between them can sometimes get fairly confusing. Zig has quite a small number of orthogonal features, and it's quite easy to sort of wrap your brain around. Rust uses a global allocator. Now, I think that may have changed recently, where they've made it easy to plug in allocators, but I'm not sure. Maybe someone can correct me. But with Zig, as I sort of pointed out in the other slides, you bring your own allocator, or you bring your own ones that are already in the Zig language. And they're two different philosophies. Everyone in Rust wants to rewrite things in Rust, make the world in their own image, whereas Zig is a lot more pragmatic, and it has the motto extend it with Zig, because of the very easy interop with C programming languages that I mentioned before. So yeah, this is what I'd say in public about what I think the differences between Rust and Zig are. This is what I would never say this in public or talk about it. It's quite immature and inappropriate, and I don't think it's really fair. But I sometimes do think these things quite loudly when I think about Rust. But I guess that's just my opinion. So, I've talked up Zig about how great it is, but nothing's perfect. There are a few wrinkles in the language, and I sort of want to go over them now, just in case this feels like a paid advertisement for Zig. So, big downside is tabs are illegal, which is just... Look, I don't want to get into a spaces versus tabs debate. It's very much I don't care, but I think it's very stupid to enforce that you use spaces for indentation at the compiler level. Apparently this is going to be removed, but why it was in there in the first place is beyond me. The big thing that has no signs of being removed is that unused parameters and functions are a compile time error. Not a warning, but an error. Which really sucks for test-driven development. It sucks for prototyping. You know, when you want to just explore a space, or when you want to write a failing test and then make it work. It's a really pedantic, picky, and bike-shitting thing to do. And if you think having unused parameters being a compile time error is completely insane, please let me know, because I think the Zig community self-selects for people that are fine with this kind of thing. And I really think they need to know how many people are just not going to consider the language over things like that. I think the reason behind some of this very opinionated or over-opinionated stuff is because the creator, a guy called Andrew Kelly, haven't really interacted with him, but he's obviously a really smart guy to sort of do the things that he's done with Zig. But he's very stubborn, and you have to be like a little bit stubborn and a little bit crazy to decide, hey, I'm going to make a C replacement. That's kind of like not a normal thing to do. So I can sort of appreciate it, you know, the sort of the stubborn genius, if you will. But I would really hate for Zig to not take off because of silly things like making unused parameters a compile time error and just ruining so many people's workflows after. It's just shooting themselves in the foot after all the things that they've just got bang on right. So thanks for watching. In conclusion, overall, I think Zig is pretty damn great. I'm very impressed. I really don't want to do systems programming in C, C++, or Rust ever again if I can help it. It's replaced them all for me, and I hope it takes off. If you want to get in contact about this or anything, you can email me. I also stream on Twitch sometimes. Sometimes I've streamed Zig, and I'm trying hard to get good at LinkedIn without selling my soul or appearing like a dick. I don't know how successful I am. We'll see. But anyway, thank you all very much for listening.